Welcome to qnawire.
So now we're going to work on problem 35 from chapter 5. In this problem, we're asked to draw Lewis structures for molecules and ions. This time, if we have resonance structures, we need to include them. And also we need to write formal charges for each atom in the molecule. So the first molecule which we're given is SeO2, selenium dioxide. And then here we have 6 electrons for selenium and each of oxygen. So we have 18 electrons total. So here we draw selenium centrally, bound to the 2 oxygens. That's going to give us a total of 4 electrons. So we can assign 12 electrons around the oxygen, and then the 13th and 14th electrons go to the central atom. However, this central atom here has only 6 electrons, so one oxygen is going to have to share its electrons with selenium. So we have a double bond. However, it could be potentially either oxygen. It doesn't have to be the oxygen on the left, it could be the oxygen on the right. And so this is where the presence of resonance structures comes into play. We can draw the exact same structure, but instead with the double bond on the right side. And this is a valid Lewis structure as well. So we can assign formal charge here by subtracting the valence electrons of the atom minus the number of electrons in the lone pairs and the number of bonds. So for oxygen, here it would be 6 minus 4 for the electrons in the lone pairs, and 2 for the bonds, which gives us a formal charge of 0. For the selenium here, the valence electrons is once again 6. We have 3 bonds and 2 lone pairs, so it's going to be minus 3 plus 2 to give us a formal charge of positive 1. And then the oxygen here we can write on top. It's 6 minus 5 valence electrons plus 1 bond. Sorry, we have 6 valence electrons. And so that gives us a formal charge of negative 1. So we can see for the molecule it adds up to 0, but we do have the presence of formal charges. And we can switch it up. For the other side, the same calculations will be the same. So for the left oxygen, it will be negative 1, because now it's the singly bound oxygen. For selenium, we're still going to have the positive 1 charge. And for the doubly bound oxygen, we're going to have a formal charge of 0. So in part B, we're given a carbonate ion, CO3 2-, and we have 4 electrons from carbon, 18 from the oxygen, and then we have, so that gives us 22 electrons, but we need to remember that we're going to have 2 more electrons coming from the negative charge, so we have a total of 24 valence electrons. So we are going to have carbon central here, and we can singly bind it to each oxygen, which takes up 6 electrons. We can assign the other electrons to the exterior of the oxygen atoms. So we have here 24 electrons, but the problem is that the carbon on the inside does not have 8 electrons. So one oxygen is going to have to share its electrons in the form of a double bond. And that satisfies the structure here. But since we have 3 oxygen, it could be any one of them. So it could be the oxygen on the left, or the oxygen on the right as well. All 3 of these structures are equivalent. So in terms of formal charge, we can draw below in the shape of the atom here. On the left side, we have oxygen, which will be 6 minus 6 plus 1. So we have -1. Any of the oxygens which are singly bound will have a formal charge of -1. For the doubly bound oxygen, we're going to have a formal charge of 0 because it's 6 minus parentheses 4 plus 2. So 0. And then the carbon in the middle all have 4 bonds, so it's 4 minus 4, so we have a formal charge of 0 for each of the carbon. And so we see that for each structure, the formal charge adds up to -2, which is what we want because we see that we have a charge of -2 on the whole ion. In part C, we're given the ClO minus ion. Here we have 7 electrons from the chlorine, 6 from the oxygen, which gives us 13 electrons, but we can't forget that we have a negative charge. So we're going to have to add 1 more and get 14 electrons total. So here, we're going to have chlorine bound to oxygen, and we can assign the outer electrons like so, and we have all 14 electrons assigned to this atom. So if we do the formal charge here, chlorine would be 7 because of the valence electrons, minus 6 plus 1, which is 0, and oxygen would be 6 minus 6 plus 1, which would be -1. So we have actually a charge of -1 here. We also had a charge over here of -2 for each of these structures. This notation here is just shorthand for the brackets. So each of this symbol here is just shorthanded for the brackets. So in our last part, part D, we're given NO2 minus. So nitrogen has 5 valence electrons. We're going to have 12 valence electrons from oxygen. So we have a total of 17 electrons, plus 1 because we have a negative charge. So we have 18 valence electrons in total. So here nitrogen will be the center atom. We can draw it singly bound to the 2 oxygen atoms, which takes up 4 electrons, and we can assign 12 electrons around the oxygen atom. And then we have 1 more to assign, 2 more to assign, so we assign them as 1 lone pair to the nitrogen. So we see that the nitrogen here is deficient of electrons, so 1 oxygen atom is going to have to share, and so we have a double bond. So again, it could be either oxygen atom. It doesn't have to be one or the other. So we could draw it with the double bond on the right instead. So if we do formal charges here, singly bound oxygen will be -1. The nitrogen, or the doubly bound oxygen, will be 0 because it's 6 minus parentheses 4 plus 2. And then the nitrogen will be 5 minus 3 plus 2, so 0 as well. So each of these molecules here has a charge of -1, which is what we want because we see the ion at the beginning has only one negative charge.